For our project, we have chosen the Student Performance Dataset from the UCI Machine Learning Repository. This dataset approaches student achievements in secondary education of 2 Portuguese schools. The data attributes include student grades, demographics, social and school-related features. It was collected by using school reports and questionnaires. 2 datasets are provided regarding performance in 2 distinct subjects, mathematics and Portuguese. As students at the end of our academic careers, we want to find the answer to the problem we have been wondering for years. That is, which factor in our life affects school success more? That's why we have chosen our main problem in this project as which attributes affect the students' grades more. We developed a project using this dataset to answer it. To begin our research, first we concatenated our 2 datasets of distinct subjects, mathematics and Portuguese. We checked for null values in our dataset and we examined the data types in our dataset. We statistically analyzed our data and to understand the relationships between the attributes, we visualized the data. We have visualized the data in subcategories while analyzing such as numerical variables, categorical variables, relationships between numerical variables, and lastly, relationships between numerical and categorical variables.
When we are searching for the effects of these attributes in our dataset on G3 points of the students, first we made a correlation heat map to look which attributes has positive correlation with G3 point and which ones has negative correlation with G3 points. And as we can see here, for example, one of the most significant ones is higher attribute, which has positive correlation with G3 points, and failures attribute has negative correlation with G3 points. And we made numerical graphics to dig deeper of the effects of these attributes on G3 points. As in this graphic, we see that the distribution of G3 points of all students in the school. And as we can see, these students have higher than average points generally, and other numerical graphics to understand our data set deeply. And these are categorical variables graphics, like address value, which has urban and rural categories. And then we are analyzing the relationships between numerical variables in these graphics. As we can see here, study time has a serious effect on G3 points. As the study time increases, the students with lower points decreases, as we can see here. So study time has a big effect on taking higher notes. And in this bar plot, we will analyze other numerical effects of G3 points of attributes. As we can see here, as the student's age increases, their success decreases generally. This may be because as the students see further education, they see harder classes, so their grades decreases. We see MEDU and FEDU graphs here. This means MEDU means mother's educational background, and FEDU means father's educational background. And as we can see here, 0 and 4 categories are the have the highest G3 points. First, I should explain what does 0, 1, 2, 3, and 4 categories. 0 is non-educated mothers. Educational background is none in this MEDU graphic, and it's same as the FEDU graphic. I will explain 4 because the others lower than them. 4 is higher educational background for means. And as we can see that non-educated mothers and fathers children have the highest grades in average. This may be because their parents may want a better future for their children, and they push them to study harder for that. And we can say for higher educational background, parents of higher educational background children has the highest G3.2, and we can say for that they want for their children a better future as themselves, or their children may seem that education gives them a brighter future and they study for that. In travel time graphic, we see that as the travel time increases, G3 points decreases. 1, 2, 3, and 4 are our categories, which means 1 is less than 15 minutes, and 2 is 15 and between 15 and 30 minutes. 3 between 30 minutes and 1 hour. 4 is more than 1 hour. Traveling between school and home takes too much time for the category 4, and it may tire students when traveling that much. And also the time wasted on traveling between home and school may wasted on study, so their grades decreases as students' time to travel between school and home. We have examined study time before. As we can see here, as the failures increases, naturally G3 point decreases. FEMREL means family relationships. As the family relationship quality increases, G3 points are increases too. It may be because of as the family relationship quality increases, the peaceful environment for students' studies provided. So it's easier to get higher points, maybe. The DALC graphic shows us that workday alcohol consumption, and as we can see here, as the alcohol consumption on weekdays, workdays increases, the success decreases. This may be because of the alcohol consumption makes us harder to focus, and this may be the reason of that the success decreases as the alcohol consumption increases. In this graphic, we see as the absences of students increases, their success rate is decreases. Attendance is important for our understanding of the classes. As the absences increases, it's harder to catch up the classes. So this may be the reason for the as the absences increases, G2 point decreases. We see here, the students who lives in urban has a higher notes than rural. This may be because of the students lives in urban tend to be more privileged. And in Guardian graphic, we see that students whose guardian is mothers, their mothers and their fathers, has higher grades than the other categories. The reason for that may be that the students in other categories have problems with family, and this may affect their study, and this may distract them. As we can see in school self-graphic, and it means extra educational support. Students who are taking extra educational support has lower grades than the others. This may be because of students with lower grades and who doesn't give attention enough to school, as they are having extra educational support with the will of their parents. And the ones who doesn't take extra educational support already attending their school and giving attention their school. And we see outlier values in the students that have extra educational support. And this may mean that the students which have already higher grades than the others may want their grades to be on the top, so they take extra educational support for that. And I guess I was going to talk about higher. Higher means the students who want a higher educational background. And as we can see here, students who want higher educational background has higher notes in average. We can say that they want academical success, so they work harder, and maybe students who don't want higher education might be thinking that they can't be successful in higher education, so they don't care as much as the students who want higher education. And finally, we will talk about the grades of students who has internet connection and who doesn't have internet connection. And as we can see in the graphic, students with internet connection has slightly higher grades than the students who doesn't have the internet connection. The reason for that may be because internet provides us to reaching information faster and easier, and it lessens the job we have to done. It makes studying easier, and students who have internet connection may have higher grades for this reason.
outliers came first among the things we thought were bad for our model. That's why we created a box plot to see outliers. And we have seen that the variable with the most significant outliers is absences. We used the suppression method to eliminate this contradiction. According to this method and the code you see, if the outliers are less than lower bound, we assign lower bound values to these values. If the opposite is the case, we set upper bound values. You can see the success of this method on the plot. Then we converted our categorical variables to numerical variables using a label encoder and put them in a state that the models can accept. Finally, if there are any duplicate values, we dropped from the dataset. We used 4 different nonlinear models. Actually, I want to explain these models. Cannon models come first among nonlinear regression models. In the Cannon algorithm, predictions are made on the similarities of the observations to each other. The closest k observation units are selected and averaged. Another model, the CVR model, is the one of the powerful and flexible and robust regression modeling technique. The aim is to determine the line or curve in the margin range so that it gets the maximum point with the smallest error. Another regression model is the classification and regression tree model. The aim is to transform the complex structures in the dataset into simple decision structures. Heterogeneous datasets are divided into homogeneous subgroups according to a specified target variable. Community learning methods are when more than one algorithm or more than one tree come together to learn and predict collectively. Among M observation units, N observation for T trees are selected by bootstrapping method. It combines T predicted values produced by T decision tree model. Here the basis of the random forest algorithm is based on evaluating the estimates produced by multiple decision tree by bringing them together. Let's examine our models in court. First of all, we have prepared the dataset to train our models. While preparing the X dataset, we also reduced the variables FEMSUB and FEMSIZE, which have the least correlation with G3 column. We used grid search cross-validation library to tune our models, and we used train test split library to divide the dataset. We divided the dataset into 4 parts as X-train, X-test, Y-train, Y-test. While we used our train sets to train the model, we used our test sets to check the accuracy of this model. As we mentioned, our control elements will be R-squared score and mean squared score. Our goal is to reach the lowest mean squared score error and highest R-squared score. After fit the Cannon model with X-train and Y-train, we used prediction function to predict our students' grades using X-test. We calculate mean squared error and R-squared error. We see our result as 1.81 and 0.78. Then we look at whether we could improve the model. So we used n-neighbors parameters. After model tuning, we reset our results to 1.75 and 0.79. Our aim the highest R-squared score and lowest mean squared error. So we didn't like these models, and we tried some other nonlinear regression models. In CVR model, we see that mean squared error was 1.69 and R-squared score was 0.80. After tuning CVR with parameter C, and our results hasn't changed much. The highest error rate in the classification and regression tree model welcomed us. But when we tuned the parameters, the results we encountered was not nearly different from the results we had with other models. The parameters in this model were max depth, mean sample split, and mean sample leaf. As a result, we decided that our safest hand to drop our model is the random forest regressor. After model tuning, we have reached our best mean squared error value of 1.62 and our highest R-squared score of 0.82. As a result, when we look at variable significance levels, we conclude that G1 absences and G2 variables are the most effective random forest regressive algorithm. Thanks for listening.